Next is prime factorization. Factorization means we have to express a number as a product of numbers. Factorization means we have to express a number as a product of numbers. If the numbers are only the prime numbers, then it is prime factorization. If we are using only the prime numbers to express a composite number as a product of numbers, then it is known as prime factorization. Then for finding the prime factorization for writing the prime factorization of a given number, we have to use two methods. One is factor tree method, which you have already learned, and other is division method. So first one, factor tree. We are writing it as drawing the tree and writing the numbers in that. Find the factors of 90 using factor tree. So 90, you have to write this 90 as a product of two numbers. The easiest way is 9 into 10. 9 and 10. So next we can write 3 as a product of numbers, which is 9 as a product of numbers, which we can write as 3 into 3. 3 3s are 9. Then we have to write 10 as a product of two numbers. 5 into 2. So look at the last step. All these numbers are prime numbers. So we can write 90 as 3 into 3 into 5 into 2. Here we are writing only the prime numbers. So final step, what we got is, first the given number is 90. We are writing 90 as a product of two numbers. So 9 into 10. Then we are writing 9 as 3 into 3. 10 as 5 into 2. Again we can't split this. So we are keeping as it is, and that is all these numbers are prime numbers. So we can write 90 as 3 into 3 into 5 into 2. Same way 60. We can write 60 as 6 into 10, or you can write as 30 into 2. That is also possible. So we can write 6 as 3 into 2. Then 10 you can write as 5 into 2. So these are the prime numbers. So we can write 60 is equal to 3 into 2 into 5 into 2. That is all these numbers are prime numbers. So we can write 60 as a product of prime numbers, which is known as prime factorization. So that is equal to 3 into 2 into 5 into 2. Next is division method. So this is very, very important. This is what we are using in higher classes. So write the prime factorization of 28. For this we are writing 28 like this, and find the least number. Identify the least number which we can divide this. So it is an even number, so clearly we can divide by 2. Then like division, we are taking the first digit. How many 2's in 2? 1. So nothing is remaining here, 0. Then 8. How many 2's in 8? 4 2's are 8. So this is also 0. So if you have any confusion, that I am not writing this. This is exactly the division. When you divide 28 by 2, you will get 14. So for this we are taking, you have to follow this method, because big numbers division is not that much easy. So if you use this method, this is easy. So first we have to take 2, identify how many 2's in 2, 2 1's are 2. Then 8, how many 2's in 8, 4 2's are 8. Then 14, least number which we can divide is 2. 7 2's are 14. So 7 is a prime number which we can divide only by 7, so 1. So we can write 28 is equal to 2 into 2 into 7. We are not writing 1 because 1 is neither prime nor composite. Here we can use only the prime number. 1 is a factor of this number, but it is not a prime number, so we can't use this. So we are not writing 1. So next is second question. Write the prime factorization of 36. The least number which we can divide is 2. You can divide by 3 also. It is also easy, but I want to show this method. 2. If you take 3 also, you will get the same answer. The order can be changed. Order of this can be changed. You can divide by 7 first, no problem for that. So whatever is comfortable for you, you have to follow that. But here I want to show a different method. If you use 3, you can do in the same way. But if you use 2, it is of different type. So when you use 2, we have to take 3 first. Okay, like the division, we have to take 3 first. How many 2's in 3? 2 1's are 2. We are using only 2 here. So what I have done is, I have taken 3 and I have identified how many 2's in 3, which is 2 1's are 2. So we are using only 2, but remaining 3 will go along with 6 and become 16. It is like division itself. I will show how it is. 36, 2. We are taking 3. 2 1's are 2 minus 1 and we are writing 16. Same thing here. You have to follow this method itself. You have to practice that. So 3, how many 2's in 3? It is 1. So we are taking only 2. Remaining 1 should go along with the 6. So it becomes 16. Then we have to check how many 2's in 16. 8 2's are 16. 8 2's are 16. Next least number is 2. So how many 2's in 18? 9 2's are 18. Then 9 we can write as 3. 3 are 9. So 3 is a prime number like this. So the prime factorization of 36 is equal to 2 into 2 into 3 into 3. 2 into 2 into 3 into 3. Next, write the prime factorization of 980. 980. Here also we are following the same method. So which is the least number which we can divide? It is clearly 2 because it is even number. 2 or 5 you can take because it is ending with 0. So we can divide by 5. It is divisible by 10 also, but we cannot take 10 because 10 is not a prime number. 2 and 5 you can take, either 2 or 5. But I am taking 2 here. So I have to take the digits one by one. First digit which I am taking is 9. So how many 2's in 9? 4 2's are 8. So we are taking only 8. Remaining 1 should go along with this 8, so it becomes 18. So how many 2's in 18? 9. And we are not using the 0, so we have to write as it is. So what I have done first is, I have taken 9 and we have identified how many 2's in 9. So 4 2's are 8. We have used only 8, so remaining 1 should go along with the other 8, which is 18 now. So then we are identifying how many 2's in 18. 9 2's are 18. So that will be cancelled and we are not using 0, which you have to write along with this. So which is the next number or least number which we can divide? We are using 2 itself. 2. How many 2's in 4? 2 2's are 4. How many 2's in 9? 4 2's are 8. We are using only 8. So remaining 1 should go along with this 0. So it becomes 10. Then how many 2's in 10? 5 2's are 10. So next, which is the least number, we can divide only by 5. Easiest way is dividing by 5. 3 is also not possible. So 5. So how many? Say, listen, I have taken 2 first. Any 5's in 2? No. So we have to take 24 as a whole. So how many 5's in 24? 5 4's are 20. We are using only 20. balance 4 should go along with 5. So it has become 45. How many 5s in 45? 9 5s are 45. Then 49. 49 we can write only the one way. It is 7 7s are 49. 7 7s are 49. So 7 1. So the prime factorization of 980 is equal to 2 into 2 into 5 into 7 into 7. Next is write the greatest 4-digit number and express it in terms of prime factors. Write the greatest 4-digit number. Which is the greatest 4-digit number? 9999. Greatest 4-digit number is 9999. And we have to express it in terms of prime factors. Expressing it in terms of prime factors means it is clearly the prime factorization. So we have to write like this. Which is the least number which we can divide? It is 3. So 3 3s are 9 first, next 9 3 3s are 9, next 9 3 3s are 9, next 3 3s are 9. Then which is the next number which we can divide? It is clearly 3. So take the first 3, 1, second 3, 1, third 3, 1, the last one 1. Which is the number which we can divide by this? It's clearly not possible for 2, 3, 5, then check for 11. 11 what do you have to do? Odd even. So odd 1 plus 1 2. Even 1 plus 1 2. 2 minus 2 0. So we can divide it by 11. So 11. First we have to take 1, not possible. So 11 as a whole. How many 11s in 11? 1. Then we are taking next number 1. It is less than 11. So we have to put 0 here. Then take both the ones together. So both the ones together means 1. I'll say this once again. We can divide this by 11. So first we have to take 1. Not possible. So 11 as a whole. So 1 time. Next we are taking next digit. No 11 in 1. So we have to put 0. Then take both the ones together. So it is 11. 11 ones are 11. This is a prime number. So we can write 9999 as 3 into 3 into 11 into 101. 3 into 3 into 11 into 101. This is the prime factorization of 9999. Next question. Write the smallest 5-digit number. Which is the smallest 5-digit number? It is 10,000. 10,000. So what do you have to do? And express it in terms of its prime factors. You have to find the prime factorization of 10,000. Which is the least number which we can divide? It is 2 we can go for. 2. So 1, no 2. So 10 has a whole. So 5 2s are 10. Then write all these zeros down which we are not using. 5,000. Or half of 10,000 is 5,000. Then again we can use 5 because 5 is easy here. So 5 ones are 5,000. Then again we can use 5. So 5 2s are 10, 200. Then we can use 2. It is 1 time 100. Then we can use 5. We are taking the easiest one. 5 2s are 10, 20. So again 5 4s are 20. Then 2 2s are 4. Then 1. So we can write this 10,000 as how many 2s? 4 2s and 4 5s. 2 into 2 into 2 into 2 into 5 into 5 into 5 into 5. Then next question. which factors are not included in the prime factorization of a composite number. So, when we write the prime factorization or when you write the factors, we are always writing 1 and that number itself. We always write 1 and that number itself. But here for the prime factorization, we can't use these two. So, that is the answer actually. Which factors are not included in the prime factorization of a composite number? We are not including 1 and that number itself.